Our next problem is, consider the reaction between calcium oxide and carbon dioxide. A chemist allows 14.4 grams of calcium oxide and 13.8 grams of carbon dioxide to react. When the reaction is finished, the chemist collects 19.4 grams of calcium carbonate. Determine the limiting reactant, theoretical yield, and percent yield for this reaction. Okay, so first let's label our equation. So we have 14.4 grams of our calcium oxide, 13.8 grams of our carbon dioxide, and 19.4 grams of our calcium carbonate. Okay, so first let's deal with our 14.4 grams. So using our 14.4 grams of our calcium oxide, let's see how much grams is produced of the calcium carbonate. So let's start with what we're given, which is the 14.4 grams of our calcium oxide times. Now we need to convert this into moles so that we can use our mole to mole ratio. So in 1 mole of calcium oxide, there's 28.01 grams. So we have 1 mole calcium oxide is 28.01 grams. Okay, now we need to use the mole to mole ratio between our calcium oxide and calcium carbonate. There's a 1-to-1 ratio. So 1 mole of our calcium carbonate for every 1 mole of our calcium oxide. Now we need to convert our moles of calcium carbonate into grams. Now for every 1 mole of calcium carbonate, there is 100.09 grams, and that is the formula mass. So we have 100.09 grams of our calcium carbonate per mole. Okay, so we plug this into our calculator and we do 14.4 times 100.09 divided by 28.01. And our answer is going to be in 3 sig figs, since 14.4 is in 3 sig figs. And our answer is 51.5 grams of our calcium carbonate. Next, we're going to start off with our 13.8 grams of our carbon dioxide, and we're going to see how many grams of calcium carbonate are produced given that amount. So let's start with our 13.8 grams of our carbon dioxide times, so same as before, we need to change this into moles. So for every 1 mole of carbon dioxide, there's 44.01 grams. So 1 mole per 44.01 grams. Now that we have moles of carbon dioxide, we can now use our mole to mole ratio. So for every 1 mole of carbon dioxide, there's 1 mole of our calcium carbonate. So we have our 1 mole of our calcium carbonate for every 1 mole of carbon dioxide. Okay, next we need to change this into grams. So we can use our same ratio as we did before. So for every 1 mole of calcium carbonate, there's 100.09 grams. So we have 100.09 grams of our calcium carbonate over 1 mole of calcium carbonate. Okay, So we plug this into our calculator, 13.8 times 100.09 divided by 44.01, and we get 31.4 grams of our calcium carbonate. Now the question is asking what the limiting reactant is, the theoretical yield, and the percent yield for this reaction. Well, in this case, the carbon dioxide is the limiting reactant since it produced the smallest amount of product, which was the calcium carbonate. So our limiting reactant is our CO2, and I'm going to circle this here. And our theoretical yield is going to be our 31.4 grams. Now from this, we can calculate our percent yield. So our percent yield is equal to our actual yield, which was 19.4 grams, over our theoretical yield of 31.4 grams times 100. So we plug this into our calculator and we get 61.8%.